Scenario. You're being chased by a horde of zombies. You can only choose one tool to defend yourself. What are you going to choose? A tap handle you could cram down their throat if you're lucky? Or a tap handle you could totally bash their skulls in with? I don't know about y'all, but I know which one I'm choosing. This bad boy. Hey there guys, Erica here from Highway 49 RC. It's been a hot minute since we've touched on the Rambii turret lathe. I know, I'm sure you guys have been waiting anxiously, but I've been doing lots of little jobs on it here and there, little projects. I've got a ton of new tools to show you. I've got updates to the machine itself. Really excited to show you guys what all I've been up to. So without further ado, let's just get straight into it with some machine and infrastructure modifications. I threaded the holes that were already in the base of the machine for some 5/8 bolts, just so I could level it and also keep the thing from wobbling around a bunch, because that's no good for getting a nice smooth finish. I got some link belt for the motor, which I did rewire, so I now have forward and reverse, no second speed. I'd have to get a different motor for that. Got some new wire to do so with, and I also wired the lamp into the same plug so that it's just one plug goes into the wall, lamp and the motor get run off the same one, which is great. I got some bronze bushings to go in this larger pulley so that I could fit this onto the motor in there for an expanded speed range. On the topic of speed, having the correct one for what you're doing is really, really important. So for me, it was really important to have an easy way to adjust the spindle speed. So I've got a foot pedal on the opposite side of the wall here, and I built this lever system to adjust the belt location. This is a whole series of drum brake springs. I'm really pleased with it. Very, very simple mechanism, super effective. The springs are just there to apply a little bit of downward force. Not that it really needs it, but just to do what I can to keep the motor from bouncing a little bit. Here's the pedal. It's held onto the main shaft by a bolt there. Put some expanding metal on here as a little bit of like grip tread. And as a matter of fact, I didn't have to drill any holes in the base at all. All the holes that I used to mount this mechanism were already in there. I made a rubber bump stop out of a automotive wheel cylinder cup, actually, that I got from work. And that is to keep the collet closer from slamming into the bearing cap on the headstock. Just because, I don't know, something to me, slamming things into other things that have bearings in them just doesn't seem like a good idea, guys. On the topic of the headstock, I did pull it all apart just because I was curious. And there is one bad bearing. I'm pretty sure it's this one that's bad. I cleaned them out real good, lubed them up. For now, they've been doing okay. It's a little bit noisy, but at some point we will have to replace them, and I will do a replacement video on that. So pretty much from here on out, any major work that I do to Rambii, which is what I have nicknamed it, I will be making a video on, because there is so little information on YouTube about these machines. With all that said, I'm going to drag these attachments over to the workbench where we can talk about them in relation to some other new things. But before we do that, there is a set of shelves that I want to show you guys. So check it out. I built this set of shelves as a storage place for all of the larger, heavier lathe attachments because I just have no place for them. So I needed to build a set of shelves. I made them super adjustable, so the shelves unclip basically. There's some notches in the side. These slip into bolts that are on the side of the frames here. So there's a bunch of bolt holes. I don't have bolts in all of them. I could put them all in if I wanted to, but for now I just put a couple in, and it is super, super adjustable. I am notorious for rearranging my stuff in my storage locations for things, so having it being modular like this was really, really, really important. The two big frame rails are made out of a piece of I-beam that I cut in half. The shelf frames are all one piece. Boy, those were a pain in the butt to bend, I tell you what. The bottoms are 1/2-inch plywood. Come here, get, there we go. The bottoms are 1/2-inch plywood, screwed into the bottom, countersunk the bolt holes, welded the corners together. Very snazzy, simple design. Simple, but way over-engineered. It was a little bit more than I had expected to get myself in for. But overall, it works great. I haven't quite optimized my setup just yet, but for now, it works really, really good. Then up top here, I've just got some miscellaneous wrenches for various things. Got a 1/4-inch ratchet with a 14mm socket on, because there's a lot of 14mm stuff on Rambii. and a couple Allen sets, because again, lots of Allens. So I figured it was a good idea to kind of keep a set of my most used tools near the machine. And here we have all of the tools that I have both bought and made, and the lathe attachments that usually sit on that set of shelves. Where to start? I'd say probably let's start with the chuck and backing plate, though I feel like the chuck is the central, most important part of a lathe. This here is a BTC branded 3-jaw chuck. Supposedly, according to the eBay seller, this is a made in US chuck, which is awesome. It's got 3 mounting bolts. They're 1/4 20, or at least that's what they came with, and that's what I replaced the ones that it came with. It's in absolutely gorgeous condition. It doesn't look like anybody's crashed it. The spanner pinholes are all pretty much in good shape. They're not overly worn out. And obviously it is super, super low profile, which is exactly what I was after in a chuck for this thing. Not only is it in super good condition, but it also has reversible jaws. Yeah, so the jaws can be put in this way, or they can be flipped 180 degrees to grip larger diameter material. But none of the teeth on the back of the jaws are broken. They're all in great condition. The jaw sliding locations are all absolutely gorgeous. They're super tight in there. I mean, really, really good quality for however old this chuck is. I really don't know. I wasn't able to find any information online on it. There's no part numbers on it, so I'm not really sure what it is, but I know it's a BTC. That's about it. Then obviously, like I mentioned, this is what's called a keyless chuck. So normally you'd have a square chuck key that would turn the scroll plate, which is what this is. So on a normal chuck, your scroll plate would be kind of buried inside it, and you'd have a bevel gear basically on the back of the scroll plate with a key that goes in with a bevel gear in there, and that's what turns the scroll plate to open and close the jaws. But this is keyless, right? So you need a spanner wrench, basically, to loosen and tighten it. You don't absolutely need one, but I made one so that I can get some better gripping strength out of it. This was a pain in the butt to bend, oh my god, but it's a pretty cool tool anyways. So obviously, how are you supposed to mount this to anything? Well, it's got the 3 bolt holes, and obviously this has to spin nice and concentrically, so you need something called a backing plate, which is what this is. This is a miniature backing plate, basically, for this chuck that I made, and this threads onto the threaded spindle nose. This is the most complicated and fanciest part that I have made since I got the lathe. Cutting these threads for the spindle nose is what I used this giant tap handle for. They are 30 by 3 millimeter threads. Also, that's the tap for it, freaking enormous. And yes, you really do need a tap handle that big for threads this large. To get the basic inner diameter prior to threading, I used a carbide boring bar that I got, and you'll notice that there are more than 3 holes on this and some set screws on the outside. That was my bright idea as to how to make this thing adjustable, because normally on a chuck, on a larger lathe, you'll have the mounting bolts, 3 or 6 or whatever, but you'll also have more bolts around the outside, and what those do is they adjust like the wobble of the chuck so that it spins nice and true. But this doesn't have anything like that. So I wanted to make something so that it was adjustable. So what I've got here are ball bearings set in holes, and I've got tapered set screws that go in and push on them. It worked once, and I was so thrilled when it did. However, I ended up cracking out the back of the cast iron here. Now you might be saying, wait a minute, this is cast iron? Yeah, it is. It happens to be class 40 gray cast iron. That is the massive chunk it came off of. So the reason I chose cast iron for my backing plate is not only because it has some of the best vibration dampening qualities out there, but because it also has good anti-galling properties, which makes it ideal for a threaded spindle. The only downfall to it, as I mentioned, is it's brittle, and I kind of didn't design this very well, so it ended up cracking out the back, and so my adjustment mechanism doesn't really work anymore. I know, big bummer. These are the plans for the backing plate that I made. I think that the drawings are fairly aesthetically pleasing, so I figured I'd show you. This is just a table of a bunch of different dimensions of bolts and such so that I could kind of compare and decide which size bolt I wanted to use for my adjusting set screws. I will be likely to remake this at some point because this diameter here, which helps locate itself on the spindle, is probably about 1/1000th too large, so there's a slight bit of wobble on it when you put it on. But once you tighten it, it doesn't move at all, and the run out is fairly good. To do the initial drilling on the back plate, I got myself a set of silver and Deming bits. And to measure the thread pitch of the spindle and the collets, I got myself a set of thread gauges, so I actually knew what size tap and die to buy. Speaking of collets and dies, I got myself a 13 by 1mm die and a 38mm die stock so that I can make my own collets at some point. I have yet to do so, but I plan to in the future to fill in the gaps in my set. On the topic of tailstock tooling, I got a number 1 Morse taper live center here, and a number 1 Morse taper 1/2" capacity keyless chuck. Once again, this is keyless, so it uses a spanner wrench, which I bought these two at the hardware store and modified one of them to fit in the hole there of my chuck. These are actually for these electrical box tension relief thingies. Yeah, I never knew such a wrench existed for these, but I guess they do, and it happens to work well for my keyless chuck. Next up, let's talk about the cross slide. One of the T-bolts that actually holds this top slide onto the lower one broke, most likely just from years of being tightened and loosened, and it just kind of got like work hardened and broke. But one thing I did notice is I was having an issue with it rocking back and forth this way on the lathe bed. And I found out that all I needed was about 1/1000th of a shim or so with a feeler gauge. I figured that out. So what I did is I made these little clamping plates that bolt onto the bottom of the cross slide to hold a piece of shim stock. This is 1/1000th thick shim stock, and it makes the cross slide super solid now. There's no rocking at all, which is fantastic. I also need to do this to my cutoff slide. I just haven't gotten around to it yet. Then obviously I've got a tool post on it now. This is an OXA sized tool post. There's 4 different sizes: OXA, AXA, BXA, CXA. They get consecutively larger. And the way it works, there's a screw inside of it that when you move the lever, pushes those dovetails down. So when you put a tool holder onto it, like so, it clamps down on that dovetail, and now the tool holder is nice and tight. This is an adjustable depth stop, so you can set your tool center real easily, lock it down, and you can just drop it on, and every time you're good to go. Don't have to worry about setting your tool height. Along with the tool post, I got some tool holders and a couple extras. I got myself some carbide insert turning tools. I already broke my parting insert a couple times, so I got myself some new inserts for that. Seems like that's a fairly common thing to break from looking on YouTube, and it's just a matter of getting things set up just right and a little bit of practice. These are the shims that I used for the cross slide, and there are also a few other indexable turning tools in here. One of these is for threading, and then 2 others that I just haven't put into holders yet and haven't used. These are both high-speed steel parting blades that I got, and I have this one set up to be used in the cutoff slide here. As far as the cutoff slide goes, I got a piece of threaded rod and a little wing nut handle thing for it. I did the same thing with the turret to hold it to the bed as well. I made a handle for it, which I am really thrilled with. It looks quite nice, and it matches the taper on the collet closer handle fairly well. And I also got a tool post for it as well. Now, the weird thing about this tool post is instead of the wedge moving down to lock the tool holder in place, this one moves up. And I don't know why. So I realized that that was actually not entirely a bad thing, because when you have a tool post in the rear position on the cutoff slide, you need your tool to be upside down because your part is rotating clockwise. So the front of it is going down, so you have your tool held normally, but on the back side is going up. So you have to have your tooling upside down. So it actually wasn't a bad thing that this wedged up instead of down. The reason you want it wedging down is so that it then helps push the whole tool holder itself down against the stop. But like I mentioned, in this case, the work is in a way going the opposite direction. So when I lock it down, it wedges upward against the stop, and it actually works great this way. Kind of goofy, but it works. So now let's talk about turret tooling. So obviously this is a chuck that came with it, but I didn't have any chuck keys for the chucks that came with the turret, so I found one. Coincidentally, I couldn't believe they had a chuck key this small at my local hardware store, and it works fairly well. It's a little loose, but for now, it does okay. I made a 3/16 adapter here for my center drill that I usually use for making links and such, but I just needed it to do some center drilling at one point. Yesterday, I made this adjustable depth stop. So here's how this depth stop would work. Basically, you would feed your bar in, you'd advance the ram on the turret until it's stopped, which you would adjust and set beforehand. You would lock your collet, well, that wouldn't move. You'd bring your turret back. You would do all your operations you need to this piece of stock, cut it off, right, so it'd be short again. You'd bring your turret back around to the stop, loosen your collet, slide the work forward, bam, lock it, and again, now basically every time you go to start your operations on your piece of raw stock, the end of it is always at the same location, so that all your parts end up being the same length. Does that make sense? I hope that makes sense. This has been so hard to try and explain. I also made myself a little depth stop wrench. Don't ask how I got the square hole in there. Man, it was hard. I used square drive bits, Phillips bits, tried to make a brooch. It was a pain in the butt. Eventually, I got it, added a knob on the back, and now I can really easily adjust my depth stop screws on the back of the turret. And finally, when it comes to turret tooling, I got myself a pair of hollow mills. Now, what on earth is a hollow mill? I'm sure you're asking. Well, it basically does the opposite of a drill bit. Instead of drilling a hole in the center of a piece of work, it drills an external shoulder. The way that these work is that they've got 4 cutting blades on them, an adjuster back here, so you can adjust the diameter that it's going to cut. You just loosen these 2 bolts, tighten or loosen this adjusting wheel on the back, and it will change the diameter of shoulder that you get on your part. Now what these are usually used for is turning down the external diameter of your stock to get ready for it to be threaded. Now, speaking of threading, I didn't get these just because I thought they were cool. I mean, I kind of did, but I also got them because we are going to be using them in a project in the very near future, which you guys will get to see, so really excited for that. Stay tuned. But I got 2 of them. They came as a bundle. I got a smaller one with a 5/8 shank and a larger one with a 1/2 shank, but I made a 5/8 expander for it. This one's the same principle, you just have 4 locking screws instead of 2 on it, and then this funky plate mechanism is so that you can adjust this to be nice and centered with your spindle, so you cut nice and concentric shoulders. Oh boy, that was quite a bit, huh? Yeah, sorry if this video was a little long, but hopefully you guys enjoyed all the updates as to what I've been working on. Now, I do have the first RC project that Rambii is going to be undertaking planned. If you guys tune into my weekend live streams, you will have heard about what it's going to be. I'm not going to say anything now, but, you know, come check out my live streams. We're usually talking about behind-the-scenes stuff there. And some of the tools that I purchased and made are specifically for this upcoming project. So, stay tuned. That'll be up in the next couple weeks. Really excited for that. It's going to be pretty cool. The hollow mills are involved, yes. So yeah, that's about it, guys. Thanks so much for watching. Hope you enjoyed the updates. If you did, please do leave a big fat thumbs up if this does happen to be the first video that you've seen by me. Make sure you go down, hit that subscribe button for more Rambii lathe content in the future. Leave a comment down below of any project ideas you have for me. And if you want to keep up with me and what I'm up to behind the scenes, including lathe stuff, Instagram's a great place. Discord's a great place. Links for those are in the description. And if you want to support me in this new machining lathe endeavor, consider supporting me through Patreon or becoming a channel member. Both of those would be amazing. Thank you so much to my channel members for making this type of thing possible. You guys are amazing. Love all y'all. Thanks so much for watching, and I will see you guys in the next one.